All right, so in this set of notes, we got two lesson objectives. We're going to learn some new vocabulary, and I want us to be able to identify a process that's either exothermic or endothermic. So that's where we're going to start. And then our next objective after that is I want us to be able to use enthalpy of fusion and enthalpy of vaporization to be able to find out how much energy it takes to melt or boil a substance. So we're starting with that vocabulary first, exothermic and endothermic. These are both words that we're going to see a lot from now on, and they both have to do with heat and either a process or an object. So if I have something and it's releasing heat to the surroundings around it, anything around it, that will be exothermic. If I have something and it is absorbing heat, so think cold items absorb heat. So if it's absorbing heat, that object will be endothermic. I think the easiest way to remember this for me, exothermic, it sounds like exit, heat is released, heat is exiting from that object. If something is endothermic, it is absorbing heat, heat is entering that object. So these help us refer to, where the heat is moving in an object. That last word there, enthalpy, that is going to be an important word we use in this class. We're going to treat enthalpy basically as internal thermal energy. So all objects, they have a certain amount of internal thermal energy. The particles are moving, they're vibrating, or sometimes moving very quickly. And that'll be the amount of enthalpy. So as the object gets warmer, its enthalpy will increase. As you give it more energy, the enthalpy will increase as well. So write these down in your notebook so you have those definitions. We're going to go over one example question, and then I'll have some questions for you guys. I have a limited amount of time in these videos, so I'm just going to flip through those questions at that time. So a question might be, in this picture, a person's holding a hot cup of coffee. Is that coffee endothermic or exothermic? So that's hot coffee. It is releasing heat to everything around it. So it will be exothermic. That coffee is releasing the heat. It is exothermic object. So here are some more questions. All right, so we know that energy increases as you heat something up. So as its temperature rises, the energy will increase. But also as a substance goes from a solid to a liquid to a gas, the energy will also be increasing. So I want you to think, if something's a solid, it's got its particles and they're moving still, but they're just vibrating back and forth. They're not able to move past each other. In a liquid, they're starting to move past each other. And then once we hit a gas, they're flying all over the place. So you can just imagine how much energy gas particles have. They have a lot of energy to be moving all over the place all the time very quickly. And in reality, if we have water, that's 100 degrees, and we have water vapor, that's 100 degrees, that water vapor, they're both the same temperature, but that water vapor has more enthalpy, more thermal energy. The particles are moving around faster, so it has them at more enthalpy than the water at 100 degrees. So I want you knowing, as it goes from a solid to liquid to a gas, the energy there is increasing. So which state of matter has the most enthalpy? All right, so I've talked about this a lot of times. I've never said it directly, so I want to make sure I cover this question directly in this class. If you have water boiling and it is if you have water boiling and you're at 1 atmosphere of pressure, so sea level, that boiling water will always be 100 degrees Celsius. So that's just something that we know. All right, running out of time here.